Hello, and thank you for joining the SDS2 and DuraFuse Frames webinar this afternoon. We're going to go ahead and get started. I am Michelle McCarthy, Director of Sales Operations here at SDS2, and joining me today is Paul Richards, Vice President of R&D at DuraFuse Frames. Just to get you guys a little bit of insight onto how we're going to work through this webinar, we're going to start off with just a little information about SDS2 and DuraFuse, talk about our partnership, and the integration plugin, and then show you how that's going to work through a demo and then open things up for Q&A at the end. So just to set the stage here, the mission of SDS2 is to set the standard of excellence for software solutions in the structural steel industry with absolute reliability and customer-driven innovation and collaboration. And I really wanted to start this webinar off with this little piece of information here because I think this is one way that we really are holding up to our pillars as a company by collaborating with a key industry partner to deliver innovation to you to make SDS2 a more reliable product. Just for a little bit more information about us, if you didn't know, we are part of the Nemetschek Group, and that is a set of about 16 brands. Some other familiar sister companies would probably be Bluebeam and RISA. And SDS2 really is focused on automating the steel detailing and fabrication processes to make you a better detailer, to make you a better fabricator. So today you'll see SDS2 detailing, and in this demonstration, what we're going to show you is how to detail projects with DuraFuse in less time, produce cleaner drawings, and deliver a more constructible model for these types of BIM projects that might use it. But one of the things that makes SDS2 really different from everyone else is that we do this automation of steel connections. And when I talk about that, SDS2 inherently has hundreds of connection types that you can apply to your model through the connection design codes that we support. But when it comes to DuraFuse, they're dealing with more seismic connection design, which can be really unique. And we have some updates to SDS2 in 2021 that will include the 3rd edition seismic design code. But the other key to supporting seismic connections is to integrate with partners like DuraFuse, because they've put innovation and engineering into creating more resilient structures with these connections that are a little bit out of the norm from what SDS2 applies automatically. So that's why we've decided to partner with them. And this really is a key to helping you guys become better detailers and fabricators and to do your jobs more easily and have like a better ease of life when it comes to using the software to deliver these partnerships with these construction technologies, because it will just make your job easier. So today we're introducing the latest collaboration, which is the DuraFuse moment frame connection for SDS2. And with that, I'm going to hand it off to Paul to let him tell you a little bit more about DuraFuse, its benefits, and how it can help detailers and fabricators.
Hello, everyone. This is Paul Richards from DuraFuse Frames. I'll be talking a little bit about the background behind the DuraFuse Frames connection. And even though those of you that are using SDS2 probably aren't engineers or getting into the engineering, I think this background information will help you understand what the connection is all about and help you appreciate what you're doing as you're detailing. I'm going to turn off my webcam while I'm presenting so you can focus on the slides. A little bit about DuraFuse. We're a sister company to Core Brace, and we provide seismic design products throughout the United States and throughout the world. A little background on DuraFuse frames. So we're used frequently for special moment frame connections, and special moment frames are used in regions of the United States with high seismic hazard. This little video clip I'm going to run here is showing a building that's going back and forth under a severe earthquake. And in high seismic areas, engineers use special moment frames that are designed to yield and dissipate energy as the frame is swaying back and forth. And the typical place for that yielding to occur is in the beams of the special moment frame. Here's an example of a moment frame building. And when I say moment frame, I'm talking about frames that don't have braces in them. Here's an example moment frame, and these red zones are the zones that engineers have designed to yield and dissipate earthquake energy. Now, in order to make sure that our buildings don't collapse, we do experimental testing to make sure that the beams can withstand these large deformations. And these are examples of typical moment frames, and maybe you've detailed some of these before. This is a dog bone connection where parts of the beam have been cut out. These are other bolted moment frame connections. But what they all have in common is that the beam is designed to yield at large deformations, the flanges will buckle. And that's the mechanism for dissipating energy in the frame. The problem with this approach to designing our buildings for earthquakes is that after a severe earthquake, you've got damaged beams. In 2011, there was a severe earthquake in Christchurch, New Zealand. These photos are of one building, both of these taken after the earthquake. This was the PricewaterhouseCoopers building in the business district of Christchurch. And after the earthquake, it looks fine. It was designed using this philosophy that I'm talking about, where certain parts of the building are designed to yield. So it withstood the earthquake. No one was hurt as far as I know, and it doesn't even look like the windows were damaged. But the beams were sacrificed in the course of this earthquake because they were designed to yield per a common philosophy. And so they had to come in after the fact and tear the building down, even though it withstood the earthquake, because it's difficult to go in and repair, take out all the beams in a building and swap them out with new beams. So the point of all this is that the way we currently design buildings in the United States, high seismic areas, and in other parts of the world, it makes buildings that are safe but not resilient, meaning they may need to be torn down after the earthquake because the damage that's expected is difficult to repair. And that was this type of experience was the motivation for the development of DuraFuse frames. We don't want to have to be tearing down buildings after an earthquake. This is just another photo to go along with that story of Christchurch. This is just showing an area of the city before the earthquake and 5 years after. And these great parking lots you're seeing are areas where buildings had to be demolished after the earthquake because they could not be economically repaired because of the design philosophy that we've used. So DuraFuse frames was developed so that you can have a moment frame that can undergo a severe earthquake and not damage the columns or beams. Let me step through the parts that are detailed in the connection. So the column has two plates that I call cover plates that are fillet welded to the column. Those cover plates have bars, or we sometimes call them external continuity plates, that are fillet welded. And then there's a shear tab that's also fillet welded to the column. So all the yellow stuff here is the column assembly. The fabrication on the beam is fairly straightforward. It's just bolt holes in the top and bottom flanges and in the web. And the connection is made with these plates that we call the top plates and the fuse plate here at the bottom. The fuse plate has an interesting geometry, and this geometry is specifically dictated in the connection design schedules. The fuse plate has regions that are cut out, and the parts that remain are what we call fuse regions that are designed to yield during a severe earthquake. And the basic idea is that rather than letting the beam yield and sacrificing the beam during the earthquake, all the damage is concentrated onto this fuse plate here at the bottom. This slide's kind of illustrating that. This is before an earthquake or during kind of moderate wind or a mild earthquake. The connection just acts as a rigid connection and nothing yields. But during a severe earthquake, the fuse plate can yield and accommodate drift and relative rotation between the column and the beam. We have done a qualification testing to get our code approvals for this connection. This is a video clip from a qualification test. I'll run it and talk through what you're seeing at the same time. So this is a column, and this is a beam, and this subassembly was tested in a laboratory. There's an actuator at the end of this beam that's pulling up and down, and that's imposing deformations on the joint that represent what happens when a building sways back and forth during an earthquake. This camera view is showing the fuse plate, so you're looking up at the bottom and seeing the fuse deform from the view of the fuse plate and the side view at the same time. I'll run through this whole clip again. The testing consists of going through a loading protocol where we start with small cycles here and move up to larger and larger deformations. And I'm going to go ahead and rerun this whole clip while I can keep talking. So the small deformations, that would represent very mild earthquakes where nothing's yielding. Once we get to larger amounts of deformation that are indicated by this metric here, this is 1% drift or 1 radian of rotation of the frame. That's when we start to see yielding. And the fuse plate, it yields in these regions, as I mentioned before. And you can see that through the fuse plate yielding and slipping in the bolts, large rotations are able to be accommodated here without damaging the beam. And so that's what makes DuraFuse frames unique, is we're not sacrificing the beam, all the damage is getting absorbed in this fuse plate. And in the laboratory, after we run these tests, we can unbolt the fuse plate and toss on a fresh one to demonstrate that the performance is repeatable. This is engineering stuff over here on the side. This plot, it's what we call a hysteretic curve, and it allows us to quantify how much energy has been absorbed by the fuse plate. This is a picture of a fuse plate when we test them all the way to the end of their life. Eventually, we fatigue the material in the fuse region, and that will break. But the amounts of energy that are required to do this are much, much higher than you could dump in from even several severe earthquakes. So this should not happen during a real event. So in comparison with traditional moment frames where the beam is sacrificed, with the DuraFuse frame, it's just that bottom plate, and so you can come in and repair buildings after a severe earthquake rather than tear them down. This repairability dramatically decreases the structural losses. This is a little technical, but it's just these curves are called fragility curves, and they indicate the likelihood that a connection will require damage. And this is illustrating that as compared to an RBS connection, DuraFuse connections are less likely to require repair for different levels of drift. And even if repairs are required, it's much less expensive to repair a DuraFuse connection than trying to take out a beam and put in a new one or replace a portion of the beam. So much lower structural losses for earthquakes. So that's one of the reasons why people are using DuraFuse frames, is because of the improved seismic resilience. Another reason people are using it is DuraFuse frames are generally less expensive than other special moment frames for a few reasons that I will mention in the remainder of these slides. But first, just to let you know, DuraFuse frames have had code approval for about a year. We've been used in several projects, and we have several others that are under construction right now, and a lot more coming down. So if you haven't detailed a DuraFuse job, you should in the near future. Our code approval is through an IAPMO ER report, and this is more on the engineering side, but these code approvals are recognized by all the jurisdictions and just indicate that we meet the requirements of the building code. And DuraFuse frames, we've been tested and pre-qualified for all the beams and columns that you'd see on typical jobs, beams up to 40 inches deep, columns up to 36 inches deep. Those are very, very robust members. Most of the time, we're much smaller than that. Let me talk about a few unique things for DuraFuse frames that make them attractive for engineers and for fabricators. One great feature that is helpful on the engineering side is there are more beam choices that are compatible with DuraFuse frames. Traditional moment frames have to meet stockiness requirements for the beam. The BF over TF ratio is strict for traditional moment frames where you're yielding the beam right here. With DuraFuse frames, since we're able to avoid that yielding and keep it out of the beam, we're pre-qualified for beams with less stocky flanges. So these shapes I'm listing here are all shapes that can be used with DuraFuse but cannot be used with other special moment frame systems. And these are common shapes that are used for gravity loading, but they just can't be used for special moment frames because of this requirement, except for DuraFuse. One great feature of DuraFuse frames is that we don't have as much lateral bracing as compared with other special moment frame systems. So as fabricators are bidding and detailing, that's one thing they'll notice is that we have much less, or in some cases, no lateral bracing at all on these beams, which cuts down dramatically on the miscellaneous steel. Overall frame weights are lower with DuraFuse frames. These cover plates are very efficient in stiffening up the moment frames that allows us to decrease beam and column sizes compared with other systems. And the fabrication is simple. So this is showing one of our column assemblies. Let me highlight a few things here. All of the welds are done in the shop. There's no field welding. All of the welds are fillet welds that require visual inspection. There's no CJP or PJP welds. There's no beam cuts or beveling that are required in connections that require field welding. There's no protected zone in the beam. There's no weld access holes, no CJP welds or weld inspection. There's no continuity plates. Those are very expensive with CJP welds on them. There's no doubler plates. Overall, there's fewer parts and fewer welds than other moment frame connections. So great features for the shop and for the fabricator. So how do people use DuraFuse frames on their projects? And if you're a fabricator and thinking about DuraFuse frames, how do you get this on a project? Step one is to contact us. Contact DuraFuse Frames, and our contact information is at the end of the presentation. And we can meet with you and meet with the engineer on the project. We provide optimization of the moment frames and help to coordinate the connection design. And so typically what we do is we work with the engineers and we do the connection design and put together the schedules for the DuraFuse connection and include those on the sheets. And then we also provide the engineers with the calculations and the other things that they need for their design review. We'll perform the frame optimization. There's a licensing fee associated with using the technology. That's a fee that's paid by the fabricator. And we can let you know that licensing fee up front when you're comparing DuraFuse with other options. And the fee that's required for the technology, it's a small fraction of the money that you can save on these through these other weight savings and fabrication savings that I've mentioned. If you decide to go with DuraFuse, our drawings will be included in the final set, and we'll review your shop drawings that include the DuraFuse frames and make shop and field visits as needed to make sure that the fabricator has the help they need to get the project fabricated well. That's kind of bringing us to the point where I'll pass the baton here. So the connection, it's very innovative and really improves the performance of buildings. And we're really excited that we've been able to team up with SDS2 with this plugin that makes the connection very easy to detail. So with that, I'll turn it over to Michelle.
So to pick up on where Paul left off, the DuraFuse plugin is something that's going to save you guys a lot of time as detailers when you're putting this into the model. If you take a look at the picture there on the left, you can see there's a good number of plates, holes, bolts, welds, material operations that have to be done. And if you're building this by hand, as we had some of our staff do, we figured out that it took about an hour per connection to model all that information in. So with the DuraFuse plugin, once we've gotten that up and running, there's about 10 minutes of setup per connection, maybe less. And then once you have those set up and you're applying them in the model, you're spending less than 30 seconds per connection to apply those in the model. So the time savings here is really huge, and it'd be really important to know if you have a project with DuraFuse that you should be using this plugin and downloading it from either our website or the DuraFuse site. The other thing to know about this is that it includes detailing templates. This will automate the drawing production for these connections and save you a ton of cleanup time as well. The final thing that we want you to know about this is that this is phase 1 of the development for the DuraFuse plugin. Phase 2 will also include the ability to import a file that will automatically place these connections in your model for you without having to reference all of the schedules and do the manual application, as you'll see in our demo now. So keep an eye out for that later in 2021. Today, what we're going to demonstrate is the detailing workflow. So you're going to learn where you can get the plugin, what to expect when setting up the connections, how to utilize the forms and minimize your data input, and then some tips for applying the connections and model and different ways you can do it, along with seeing how the detailing templates work and correspond with those connections that you've applied to the model. So starting off, where to get it. Paul already mentioned this, but it's important for you guys to go home with this information. You can get this from the DuraFuse website or from the SDS2 website. And I've just shown on the SDS2 website where this will be located. And if you click on the DuraFuse frames, then it'll open up an area that'll give you some links to download the plugins, and that will include both the component and the templates. So one more thing before we get into the demonstration, I want to show you an example again of these drawings because these are the references you're going to use to input the information. So the drawings are going to include, as you can see here, are one-sided and two-sided connection schedules. In these sample drawings, the schedules are blank. But when you're working on a project, these areas are going to be filled in with information about each of the connections, and that's what you're going to reference to input it in into the connection component. There's one more sheet that I don't have here that will be the plate schedules for the top, shear plate, and fuse plate, as well as the beam end operations. And then the final item that you'll reference is the elevation view, so you know where to place all of these connections from the schedule in your model. So with that, we're going to get into the demonstration now. So we've opened up our SDS2 model, and you can see this is partially completed. And so we've got a few of those DuraFuse frames already on. Now we're going to go to grid line G and apply a frame from scratch between column lines 4 and 9. So the way the DuraFuse plugin works is you're going to reference this drawing to figure out what connection type you need to place, and we're going to start with the DF103. So we'll go to the one-sided connection schedule. You would look at, again, a filled out schedule that would show you the DF103 variables, and then you would also reference this next sheet to get the plate variables that we'll input into the component screen here in just a moment. So we just want to show you that so you know where this information is coming from. Now we'll pre-select the column, click on the component add type, and you'll see the DuraFuse component. When we select that, it will bring up the edit screen where we can fill in all of our variables. One of the most important things to note is that that elevation area that we've highlighted, if it does not detect a beam top of steel at that elevation, it won't give you any options for the connection. So once we type those in, then you have options for the connection type and the connection side, which we'll see there right below the DF103. From here, this is where we would start to reference our schedules in those drawings supplied by DuraFuse. As you input each of those variables, you can also reference the images at the right to kind of see what those variables control. And there's a note over here at the right. If you do not have variables for fields 4 through 7 in the plate thickness settings, then you just reference either the T2 field or the horizontal shear plate calculation there that they've provided. So this process does take a few minutes, but as you input that in, then you can place this wherever this connection occurs throughout the model. As we get into the weld settings, you can see that the tail text is pre-filled out with some defaults. So you shouldn't have to touch those, but those fields are editable if you need to. And you can also use the standard copy paste options as well to paste in different weld sizes if they're all similar or all the same. If you have a field here, like we'll see with an example in just a moment of the W8 field for the 8th weld, where there wasn't one provided. And in those cases, if there's not a weld called out for it, if you put in 0, it will basically just skip that weld. Moving down into the bolt settings, you'll input your diameter, your spacing, your bolt types, and a few other variables that you'll pull from those schedules that are provided by DuraFuse. And these final 4 fields are where you'll move over to the second schedule to reference the top plate and the fuse plate dimensions, as well as the shear tab and the beam settings. So once these fields are filled in, the next step is going to be to save off this input as a form. And I don't know how many of you are familiar with using forms in SDS2, but this is a way to save your input to be reused in different modeling sessions or by other users on the project. So what we'll do here as we finish up is on the lower right next to the OK, you'll see a copy, paste, save, and a file folder. Those are your form save options. And we'll use the file save option to name our component form. And then you'll see that we also have a whole list of them that we've done for the entire project. And we would recommend this to anyone using the DuraFuse component right now, is to do this setup work at the beginning and then go do your modeling. So we'll type in DF103, that'll be the name of this connection. And now this will be available to us anytime we need to load that for the next time we need to place a DF103. So you can see that's been input in the model and saving a lot of modeling time there. Even the setup time is less than what it would take to model that. So over on now the right-hand side, we'll put in the other DF103 on the near side. So pre-selecting the column again and picking the DuraFuse component. When we open the screen, it will actually remember the last one that we put in there. So it does already say DF103, but it still is holding the far side for that connection. This is just an example of how you would load the form. Click the file folder, open it up, and then change this to the near side because it is the opposite side connection. So now we've placed our other connection on this top of steel level. So then we need to fill in the columns in between. And at this step, we're going to take another route to getting the DuraFuse component on. And we're going to edit our toolbar configuration to add a DuraFuse component button. This just helps save you some clicks and can make you more efficient while you're on a DuraFuse project. It can be added or removed at any time. So this would be a handy way to just to keep it quick when you're adding these types of components in. So in this case, pre-select the column, click the DuraFuse button, and it takes you right to the edit screen. And then we will load our next form for a two-sided connection, which will be a DF203. And in this case, we don't have to do anything with it other than load the connection. It's reading that connection elevation that we've saved into it, and it applies the connection. The nice thing is we can also multi-add. So we'll pre-select 3 columns. Again, it remembers our DF203, so we don't have to even load anything and just hit OK, and it'll apply those connections for us. One of the things you'll notice when you're working on a DuraFuse project is that along that same elevation or on that same height at that 23 foot, those connections are all going to be similarly named. So the interior double connections are all going to be DF203s, and the 2 end connections are going to be DF103s. Then the next elevation, they're going to be the same, using the same connection at that elevation. So in this case, we've now pre-selected the column, added our one-sided connection for the next elevation, which is a DF105, I believe. Now we're flipping that for the near side. And again, it adds in pretty quickly. And this is why we recommend that you take the time up front to set up all the forms for it. Spending that time earlier will pay off in the time savings once you can go through the model and work consistently through it. Doesn't break up the rhythm every time you have to input the information. So now we'll add our DF207. And again, this really moves pretty quickly once you have the information set up for it. And now we'll move on to the top elevation. And in this case, it's reading the elevation that we have saved there at 71 5 3/4. But if we click on the beam, we'll actually see that the top of steel is 71'6" because they could be raised just a bit above the top of steel for the column. It's going to be important to note that because it will not detect at that top of steel for the column, it will not detect a connection type being available. But when we change it to the top of steel of the beam, you can see the connection type does pop up. Now we would reference our elevation view to see what connection we need to place. And when you fill out that form, it was bumping that up. So we just deleted the extra 1/8 there and it should apply our connection. Another way to get to that is to just click on the beam first to verify you know what connection elevation it needs to be and copy paste that in. And for our last step, then we just need to fill in these center columns again with the two-sided connection at the top. So we can select them all, load our form, remove that extra 1/8 there, and we've got our connection for this grid line finished out. So I think you can fairly well see that the amount of intensive modeling this would take if you were trying to attempt this by hand is significantly reduced by just a little bit of time spent up front putting together your setup. So now we'll move on to detailing so you can see what these drawings come out like. We will detail this column and we're going to make sure that we have our detailing templates on because it does use the templates to do the cleanup for you here. So when this completes and we open up the drawing, this is going to be your detailed drawing. There's a lot of information here, but we worked with DuraFuse to make sure that all the appropriate information was included and the drawings would come out as expected for review. So you really shouldn't have to do a whole lot to clean these up or work on them. So that concludes our demonstration of the SDS2 and DuraFuse plugin. At this time, we'd like to open it up for Q&A. All right, so we do have a few questions coming in, but while I ask this first one, we're going to open up a poll question for people to answer. So as we open that up, we will ask, where can we download this on SDS2? That can be opened from the integrations and the toolbox areas on the SDS2 website. While people are voting, we'll do one more here. Paul, this one's for you. Will DuraFuse keep up with the SDS2 versions?
Yeah, absolutely. And as was mentioned at the beginning of the presentation, this is just phase 1 of our implementation. So as you get in and you're using this tool, just check back regularly with us or with SDS2 to make sure you have the most current version. I expect that we'll have several updates next year and in the coming year, and then into the future we'll continue to maintain it. It's a great tool for helping to use DuraFuse on projects.
Okay, great. Thank you, Paul. So let's close this poll and just kind of see what the answers come up for that. So there's a few of you out there that have used DuraFuse connections on a project in the past, but the majority of you here appear to be new to it. So thank you for joining us and learning a little bit more about it. I'm going to have the next poll question open up for you guys, which will be here. Will this new integration encourage you to bid on projects with DuraFuse connections that you might have avoided in the past? So if you guys want to vote on that, we'll go over to our next question, which is, how does the component work with pitched roofs? So Paul, you might have to answer that. Yeah.
Is that for me?
Yeah.
Oh man, I'm an engineer, not a detailer. So yeah, so DuraFuse connection, it is compatible with pitched roofs. I think the plugin that was demonstrated today, I don't know that the capability for pitched roof is built in right now, but it's a good starting point. And so on some of those special details, we can work with the detailer to make sure that there's no confusion on that, but look for that in upcoming releases too. And as was indicated, a lot of you haven't seen DuraFuse projects yet. We've just had code approvals for a year or so. And so we've only done a dozen buildings or so that are built or in construction right now. So hopefully you'll be seeing more of those coming down the pipeline, and the plugin will continue to increase in capability.
Great, thanks. The second part of this question is from Chris Garcia. Would it be possible for DuraFuse to provide the FRM forms rather than have the detailer input them? I think, answer this, and you might correct me if I'm wrong, Paul, but the DuraFuse connections are so different across every project that we can't really provide all the standard forms to them. But in phase 2, we'll actually have, it's planned to have an import, so you won't have to fill out those forms forever.
And that is correct, and that'll be available in just a few months, and so that is correct. So for the time being, we could help you if that's a deal breaker for you. We could help you populate those forms, but they are specific for every project.
Right. Next question. Is the bottom fuse plate, is it a steel plate?
Yeah, that's a great question. So all of the material in the connection is standard steel plate, A572 grade 50 and that's for the fuse plate and for all of the other plates in the connection.
Okay. I'm gonna go ahead and close this poll out so we can see the results of that really quickly. So that's great results. We got the majority of the group that are on here. This will be a big help to you guys, it looks like. So I'm glad you've joined us so that you do know that this is available to you in the future and can help you get in on maybe some more projects. Next question, is the connection still possible when the beam flange width is wider than the column flange width?
Yeah, that's one of the really cool things about this connection is there's a lot more flexibility in beam and column combinations. I don't think it's probably beyond the capability of the current plugin, but we do have details that handle that, and that shows up in unique cases. But we can handle beams that are wider than the column flange width.
Okay, great. Next question. Is there a biaxial DuraFuse connection available?
Yes, there is. And again, it's not built into this plugin yet, but we do have details and designs available for biaxial. We're pre-qualified for use with HSS columns, box columns, or cruciform columns.
Okay. What purpose does long slots provide in the fuse plate, or what is the purpose of those long slots in the fuse plate?
Yeah, so the part of what I'm trying to think. I don't know that there are long slots on the fuse plate themselves. The bolt holes in the fuse plate are oversized holes.
Okay.
And that's to accommodate fit up and erection. On the top plates, there are oversized holes and long slotted. And those are to accommodate fit up and erection to make it easy to put the connection together on site. The other benefit of that is during severe earthquakes, when the connection is undergoing those large deformations, part of the deformation is accommodated by slipping in the bolt holes. And so those long slots enable us to dissipate energy and achieve large deformations without damaging the beam. That helps in addition to the fuse yielding.
Oh, good. Boy, I'm glad you're here to answer that question. Let's see, there's a question up here above are there any connections to the web? Everything's going to the flanges of the columns.
Yeah, that's a good question. So when you have beams that are framing in from the orthogonal direction into the columns, we have details that just have a shear tab that's attached to our cover plate at the connection. So I don't know that that was demonstrated in the demo, but typically we will have stuff framing into the orthogonal direction of the column. But generally, those attachments are being made to the cover plates that we're putting onto the columns rather than to the column web itself.
Okay, great. Do we have DuraFuse plate connections available for HSS columns to HSS beam moment conditions?
We are not pre-qualified for HSS beams currently, but we do have pre-qualification for HSS columns and have details for all those configurations.
Okay, questions are slowing down here a little bit. There's a question here about, well, more of a follow-up on the forms, is that there's probably a specific spreadsheet that we could use to populate the form fields, but I think really with the next version of this coming here in the next few months, 4 or 5 months maybe, it's a short time frame where you'd have to do that hand input and then have the update that'll do the import instead. That would save you the work there, but that's something we can look into.
Yeah, and that's correct. And our goal, we wanted to get it into people's hands right away. We've got a lot of projects that are coming through, and we didn't want to hold up people from using what we have while we take another month to get some of those automation features built in.
Right. Can you show the detailing templates for the top and fuse plate again? So we'll switch to showing a screen here. Just a second. There we go. So if we take a look at those, this is the top fuse plate or the top plate?
Yeah, the top plate, we don't call it a fuse, so just the bottom plate is the fuse plate.
Okay. So part of the plugin, and what's nice for you guys as detailers, is that there are templates, and this is the template output that we worked with DuraFuse to make sure you guys wouldn't have to do the cleanup for this, and that should be coming out as expected or as desired, to provide all the information without a whole bunch of extra things or without dimensions going all over the place. We try to keep it pretty neat there. One thing that's unique here so this one is the fuse plate, correct, Paul, with the hatching on it?
That's correct.
And what is that hatching supposed to indicate?
So that hatching is indicating what's called a protected zone. For special moment frames, the requirements for the code are that you have to designate a protected zone, which is the zone that's expected to yield during an earthquake. And so detailers may be familiar with, typically that protected zone will be in the beam, a region of the beam that's designated the protected zone. For DuraFuse frames, the protected zone is just the fuse plate at the bottom. And so I don't know that it impacts the detailer that much. Down the road for the contractor, they need to keep track of that and make sure that that's indicated in the field.
Okay. Let's see, can this connection be applied to smaller beam and column sizes like W10s or W12s?
Yes, that's one of the great features of this connection is it scales down very easily. To be honest with you, I don't know that we've designed one with the W10 or W12, but I can't think of a reason why we couldn't. Often the moment frames sizes are dictated on the engineering side for drift requirements as far as getting the building stiff enough so that it doesn't flex too much during an earthquake. And typically it's difficult to meet those requirements with small shapes, but there's not a reason why we can't go that small.
Okay, great. Well, I think that's the last question I've had come through here. Oh, nope, something just popped up. No paint on the plates and the fuse plate. What is the typical material grade?
So the typical material grade is A572, grade 50. And the plates can be painted, but the fairing surfaces need to have a Class A fairing surface. So if you do paint it, just check to make sure the paint is rated.
Okay. Another one popped through. Can we paint the framing at disconnection? I think you might have just answered that. All right. Well, this has been really informative. I appreciate you taking time out of your day, Paul, to help us share this with our user base and get the word out here about the integration that we have with DuraFuse. If anyone has additional questions after we wrap up, we will definitely answer those. Actually, one did just pop in here. Can we have any welded connections in lieu of bolted plates?
Yeah, that's a great question. So the reason the fuse plates are bolted is so they can be taken off and replaced during an earthquake. We do have details. So we don't have details that where the fuse plate's welded on, but we do have details where the top plate is welded on. We can discuss that with the engineers. Part of the reason for bolting too is to accommodate the erection sequence. It's helpful to have the plates be movable while we're positioning the beams, but there are some possibilities there. And for people that are detailing in lower seismic areas, or if you're interested in using DuraFuse but care less about the repairability and some of the other things, but just want the other benefits that we have, we do have variants that reduce the amount of bolts.
Okay. All right, well, I want to thank you again, and thank you all for attending today. This video will get posted up to our YouTube channel here if anyone wants to come back and reference it. And again, if you want to go to download the DuraFuse Frames component, it's on our website. And we'll be continuing to update as we have the new features that we add to it. All right, well, thank you all. We look forward to seeing you guys all at our next webinar. Thank you, Paul.
Thank you. Have a great holiday.
You too.